Welcome. So in the last video we saw that for basic current mirror we know some circuit is connected here, I not this. So for basic current mirror VDS1 VDS2, so for basic current mirror, for perfect matching we need VDS2 is equal to VDS1. Okay, so we are going to design the circuit such that the VDS2 we will make VDS2 is equal to VDS1. So there are two ways. One is we have VDS1, okay, and we will make VDS2 as equal to VDS1. So VDS2 is equal to VDS1. Second way is we will fix the VDS2. Okay, we will fix the VDS2 to some voltage, and we will see what is the voltage in the next video. That will be the minimum voltage requirement for the device to be in saturation, and that is the overdrive voltage of the two. So we will fix this VDS2 to some voltage, and that is overdrive voltage, and we will make the VDS1 is equal to VDS2. So there are two things, though the relation is same, but in one case we are making VDS2 same as VDS1. In another case we are making VDS1 same as VDS2. So this is independent, this is dependent, and here this is dependent, this is independent. Independent means we will fix the voltage what we want, and dependent means we will design the circuit accordingly. Okay, so one of the one method is in this case what we will do, we will decide, we will make VDS2, what we will do, we will make VDS2 equal to VDS1. That is, this voltage we will not touch, it will remain as it is, the circuit will remain as it is. Okay, this circuit will remain as it is, we will not touch this circuit. We will make change in this second right side. Okay, so first this will remain as it is, VDS1 will remain same. We will make this VDS2 equal to VDS1 by making the this right side circuit changes. Okay, so let's go deep how we can do the changes. Okay, so one of the method, if you see, so the purpose is to make this VDS is equal same as this, and we have made this, we are not making change anything here, we are making change in this way, in this side. So we want this to be, this voltage VDS2 to be same as this VDS1. So what we do, okay, we have, let's say, VDS1 available, that we want, let's say 500 millivolt. Okay, so VDS2 we want to be equal to 500 millivolt or something same as VDS1. Okay, so what we have done here, we have added one more M3, okay, one more nmos above this we have connected here between the circuit and the device, copying device, a device, an nmos, and we have some bias voltage here. Okay, we are going to make this VB as per our requirement. And what is the requirement? It is 500 millivolt at this, across this VDS2. So we know that we want 500 millivolt, and that is VDS1 across this, and we will decide the VB value according to this. And this device is connected between the main circuit and the lower one, wherever you are copying the current. Okay, so how we will make this? So we will fix this voltage VB. What is the VB? VB is equal to VGS3 plus VDS2. This we know what we have to make. It should be equal to VDS1. And this we will make VGS enough for the saturation condition. Okay, so this voltage is defined by this VB minus VGS3. Okay, and this voltage, whatever the voltage comes here, varying voltage, whatever the voltage comes here, will not affect the VDS. This will not affect this here. Why? Because this VDS, this VD2, let me write here, VD2 is defined by VB minus VGS3, and VB we will make from the another circuit, and we will fix that voltage such that VB will be equal to VGS3 plus VGS, and VGS2 will be, so it will be VGS3 plus VDS1. And how we will VGS3 will be decided? VGS3 will be decided by, we know from the equation that VGS3 will be under root of what? 2I naught mu n Cux W by L plus VTH. This we will know that whatever the current we need in this branch, I naught, will decide the VGS3 value. Okay, so this VGS also we know how much we need based on the size of the W by L3. Okay, so based on the size of the M3, we will decide the what is the VGS requirement, and then we'll fix this voltage VB. This voltage will be fixed. Okay, and by this way this voltage is also fixed to VDS1. So here if you see that VB will decide the value of the VDS of M2, and that voltage we will fix to equal to VDS1. So this is the first concept here. By what is that concept is, we will add one more circuit, add one more MOS above the, let's say it is a copying here. We will make this VB such that this is VDS2 which is equal to VDS1. We know what we want from here. Let's say from the reference circuit we know that VDS1 is equal to, let's say, 500 millivolt. Then we will make this 500 millivolt, and this VGS, how we will calculate that? VGS is equal to, we know from the equation that I already mentioned here, this one, this one. Okay, so by this method we will know that we have a VGS value also fixed, function of I naught and W by L of 3. Okay, and if you want I can write it again from the equation that VGS3 is equal to 2 I naught mu n Cux W by L 3 plus VTH, or whatever the equation it will be. The point is I naught is also, we know that what we want. W by L we will decide, we will make the size, and for that I naught and W by L3 we know what is the VGS required. Okay, we will not make the size change, we will make this W by L3 fix also. We will see how we will make this W by L3 W by L, okay, sorry. So this W by L3 we will make some such that it will be in a saturation or whatever it is. So we know that I naught what is the value, W by L3 what is the value. So based on that we also know VGS value, and VGS also we know and VDS also know, and we will then decide the value of VB. Okay, so one of the circuit is that we will have the one cascode. This is called as cascode MOSFET. Okay, above the this. Okay, now going further, you see in somewhere you will see that it is mentioned that the shielding effect. So what does it mean? It means that M3, this MOSFET, this M3 will shield M2 from the above circuit, this circuit. Okay, let me give you another view. So this M3, M2, VB, by adding this M3 in between this M2 and circuit, we are shielding M3 from the circuit, above circuit. How we are shielding? We are shielding because what does it mean is that this voltage VD2 is now defined by VB, not by the circuit above. So that is the meaning of this. Okay, now let's go further. What does it how we will decide the value of VB. Okay, so this I already mentioned about what is the value of VB. So we know from the equation, from the circuit, we know that okay, this value VDS2, so this will be plus minus VGS3 VB minus VGS3 will be equal to VDS2. Okay, and this we want equal to VDS1. So this is that, and from the current mirror circuit we know that VDS1 is equal to VGS. Okay, so if you see closely VDS2 this by this equation, whatever mentioned here, that VB value, let's do it fairly. VB value is VGS3 plus VDS1 and VGS3 plus VGS1. So this is two drops, two VGS, two diode connected device. So to generate the VB, we need two diode connected device. This is what I understood, and this is what we should feel from the VB equation, that there are two VGS requirement. One is VGS3 and one is VGS1. VGS1 we already have. How VGS1 we already have from the circuit? This is VGS1, this is VGS2, this is VDS2, this is VGS3, this is VB. So VB voltage is equal to VGS3 plus this, and this is made equal to this VDS1, and VDS1 is also equal to VGS1. So VB is two diode drop voltage. One is this and second is this. Okay, so this already we have. We just need one more voltage VGS3 to generate VB. So how we will do that? What we will do, what is done is we will create one more drop here, VGS3. Okay, same as this from the IREF, and we will connect this to here. So this will generate VB here. How it will be it will generate? If you see, this is VGS3 this side, and this is also VGS1. So whatever voltage here will be connected to this side. So your final circuit will be look like here. So final circuit, how it will look like? Something like this. Okay, let me go with the story. So we already have this with us. So we already had this with us earlier, and to make this voltage VDS2 is equal to VDS1, what we did in one of the way of, we added one more MOS here and we make this VB, we have make this VB such that this VDS2 is equal to VDS1. This is bias voltage and this is VGS3 and this is VGS1. So we need these two voltages, one voltage and second voltage. For that we have created one more. What we did, we have removed this, we have added one more here and we have generated plus minus VGS3 here and this is VB. So what we did, we have connected this here. Okay, by this way we get VB also. So final circuit, how it will look like? Okay, this will look like here I mentioned. So it will look like this. So if you see from left side, this is VGS1, this is VGS3. Okay, we will make equal this VGS4, this is VGS4, we will make equal to VGS3, then only it will work. Otherwise it won't make this voltage plus minus VDS2, it won't make this voltage VDS2 equal to VDS1. So for proper working, means what we make, this voltage has to be equal to VDS3. From the designing, W by L decide, you will decide the W by L of 4 accordingly, such that your VGS4 is equal to VGS3. And how you will design this? So it's very simple. We know that we have IREF. Okay, we know what voltage we need VGS3. Okay, we know we have VGS3 requirement from here and we know what is the IREF in this circuit. So from there we have one equation that IREF, whatever the current going, IREF half mu n CUX W by L4 VGS4 minus VTH 4 whole square. So what are the known things here? So we know this IREF, we know VGS4 is equal to VGS3. Okay, so by this we can find what is the W by L requirement of the this device. So by this way we can design the M4. Okay, so what is the conclusion here? So conclusion is, let me summarize this. Okay, so the conclusion is that okay, so conclusion is this. I already mentioned before, but let's see, because this is the way how we make the circuit. So conclusion is, for VDS2 be equal to VDS1, we will design this circuit, we have made this M3 connection added between the circuit and the M2. Okay, and W by L3 we know how to decide. So something we should know, either W by L3 in W by L we should know, or VGS3 we should know what is the your requirement. Okay, so we know VB requirement is VGS3 plus VDS1, and VGS3 plus VDS1 is VGS1. So two drops. So what we did, we added one. How we have designed this extra VGS3? We need extra VGS3. So what we did, we added one more diode connected here, and this value should be made equal to VGS3. Okay, VGS4 equal to VGS3. We have made from the IREF value, and we design this W by L4 accordingly such that VGS3 will be equal to VGS4 equal to VGS3. Then we will take this node voltage and we will connect this here. Okay, so the final circuit will be, so it should be in a visual that there are two diode connected. One is here. So ideally this was the copying thing. This is to be shielding. This node voltage we needed. So what we did, we have connected this here. Okay. So this is by understanding. If you go with the memorizing the circuit, then you will see something like different views, something like this. Okay, so this is your memory. IREF, this W by VG, this is 3 2 1, this is 3, VGS3 is equal to VGS. This M4 VGS should be equal to this, then only it will work as the diode, as a current mirror. And most important thing is that, what is the most important thing here, that this voltage VDS2 is equal to VDS1, and if W by L of 2 is equal to W by L of 1, then I0 is equal to IREF. What is I0? Current through this. There are other circuit, current through this branch. Okay, so the purpose of all this circuit is to make this VDS2 equal to VDS1. This total VDS should be equal to VDS1, and we have not made any change here. Okay, so this is the one of the circuit where we make the VDS2 is equal to VDS1. So this is one of the circuit, and let's see. So what is the problem here? Before going to the problem, let us do designing more, that how to design and what are the factors we need to consider. So this is what we know, that for the same current, both aspect ratio should be same. Why? Because we know from the basics that whatever I0, IREF, both VGS are same. So from the current we know mu and Cux W by L VGS minus VT whole square 1 plus lambda VDS. If these two VDS, if VDS are same, then I0 upon IREF, VDS factor will be gone. So what factors will be gone? These factors will be gone. This and this and this and this, because VGS is also same and VDS is also same. We have made VDS2 to VDS1 from the above circuit. Okay, then the equation I0 upon IREF is equal to W by L of 2 by WL of 1. Okay, ratio of two aspect ratio will define the ratio of the two currents. So if we want same current, we will make both the same aspect ratio. If we want some ratio, then we will make accordingly. So this is the designing of M1 and M2. What is the W by L we need? Similarly M2, M3. So M2, M3, how the circuit will look like now? We know this is M1 and M2. This is already been designed, and we know VB how it will come. We will make this diode connected, and whatever voltage we are needed, VB is generated here, because this is VGS3 and this is VGS1. We needed VGS3 here, and this voltage VDS2 should be equal to VDS1 is equal to VGS. This voltage is equal to VDS1, and this is also equal to VGS1. So this VGS1, VGS3, this is already made by the designing, and this is all we have VGS1. So this voltage and this voltage are same, so we connect this here, because this is voltage generated here, VB. Okay, so this size we have already designed M1 M2. Now this W by L of 4 and W by L of 3. How we will design this? The same process. We know the current in M3 4 and 3, we know the currents. So by the same current equations, if we write that, we have made VGS4 is equal to VGS3. Again we will see this thing. Okay, why we have not added the effect of, curious thing, very important, why we have not added here the lambda effect, 1 plus lambda VDS 3 upon 1 plus lambda VDS 4. Why? Okay, so if you see clearly, why we have not added? Because we'll I'll see, and I'll come to on this point, that why we have not added 1 plus lambda VDS effect here. Okay, right now it's not clicking in my mind, but I'll come to you on this. What is the point, that why we have not made the ratio? Okay, so if you get this point, it's good. You'll just let me know, you know. Okay, so similarly as M1 M2, we have I0 and IROF, and we same VGS, so same aspect ratio of aspect ratio will remain same, because current will remain same, the ratio will remain same. So by this way also we can design the M3 and, okay, so it is M3 here, M3 and M4. Okay, so it's simple, just like I0 upon IREF is equal to W by L of 2 by W by L of 1. Similarly we have 3 by 4. Okay, because in this branch current will remain same, I0 and IREF. Okay, I'll come on this point. Okay, now going further, what is the conclusion? What we see here is, for same current we need same aspect ratio between 1 and 2, and if L1 and L2 are same, means these two devices are same, L1 and L2 are same, then W2 is equal to W1 for same current. Okay, similarly for the Cascode also, connected here, the L3 and L4, if L3 and L4 are same, these two lengths are same, then for same aspect ratio we have to have both sizes, W3 is equal to W4. Okay, but if we want some different I0 in the ratio of n, then we need have let's say if the sizes are same between L1 and L2 and between L4 and L3, if the sizes are same, L1 L2 length, both length are same, then the ratio the sizing width will be defined by this ratio n times of W1. So what we have learned here is simply nothing but how to design in actual world. L1 and L2 are made same. Then if W1 is this and IREF is this, if we want n times of IREF, then W2 is equal to n times of W1. This is simple thing. Similarly for the Cascode one. Okay, the above one W4, this is W3 is equal to n times of W4, making we know that L4 is equal to L3. Then so this is what I have mentioned here. Now going to the last point. So what is the last point? It says from the previous video we know what we have. We know that for no lambda effect, we know length should be high. Okay, so what does it mean? It means 1 plus lambda VDS upon 1 plus lambda VDS if it is there, VDS2 VDS1, I naught upon IREF if it is there. Let's say VDS2 is not equal to VDS1. Okay, and let's say if it is made equal to VDS2 is made equal to VDS1, then for I naught equal to IREF, and this is lambda 2 lambda 1, lambda 2 should be equal to lambda 1. And what does it mean? It means delta L by L is equal to lambda VDS. So this lambda is made small so that the effect of this whole factor will not come on this current. So this is simple thing, that for proper matching, length should be high. Okay, let's say if you will make length small, lambda high. Okay, so if lambda is high, so even though you have made 1 plus lambda VDS is equal to this is also equal to this is both lambda is also equal to this is also equal to this, same. I know, means from this equation we know that this ratio will become will be 1 if both VDS2 is equal to VDS1 and both lambda is equal to both lambda 2 is equal to lambda 1. But in the process, it will never happen that lambda 1 is equal to lambda 1, first thing. And second thing also, the VDS2 will not always equal to VDS1 because of the mismatch, because of the other things. So okay, let me tell you one thing. This is deterministic thing. VDS2 is like we can decide, but lambda factor, L factor, random mismatch, all those things, to avoid all those things, we make this lambda equal to very low. Okay, even though VDS2 is equal to VDS1, this lambda will not always equal to lambda 2 is not always equal to lambda 1. Okay, so to avoid this all mismatch thing, the variations, we make this lambda small. And how it will make, the length will be increased. So this is the point mentioned here, that as we increase the length, lambda effect will be gone, and we make L1 equal to L2 equal to high, both the lower devices M1 and M2. The Cascode one, the upper one, basically this is a device, and this is a diode connected, and this is the Cascode, and this is the bias voltage generated here, and it is connected here. So this is not made high because the purpose of copying the current is made here. Once the I naught is equal to IREF or it is matched, then we can make this L low, both L3, L4 and L3 we can make low because of this. Even though we can make if we make high, let's say, there will be no issue. If we make low, length is made low, then also there is no issue. Why? Because I naught and I ref are defined, means I naught is defined by the M2 and M1, not by M4 and M3. Okay, so this L3 and L4 are made small, and this M1 and M2 length are made high. And why we make length high? Because lambda goes down, and lambda goes down, the effect of VDS or effect of lambda or effect of length. So what is mismatch? We'll see all those things. So because of the process or different thing, L1 is not equal to L2, and once L1 is not equal to L2, lambda 1 is not equal to lambda 2. So to avoid the effect of lambda effect on ID, we make lambda is small, such that even though lambda 1 is equal to not equal to lambda 2, but lambda itself is very small, so the current will not vary much. Okay, so this is the basic understanding for the matching thing, that proper matching we need less lambda or length should be high. Okay, because mismatch and all these things are a random thing, and it will be like process or this process we will see later, that L1 will not be equal, even though we make the circuit L1 equal to L2, but in the process it will not equal to L1 equal to L2. So because of that, lambda 1 is not equal to lambda 2. To avoid that effect, we make length lambda small and length high. So this is the final thing. And by this, what is the conclusion? So the conclusion is this thing, that we have this circuit, these two MOS here, and we have connected one MOS here, and to generate this voltage we have connected one MOS diode connected here and connect that terminal to this. And what is the problem? So final thing is this, this was the design. So okay, the final thing is, I'll tell you what is this. So one major thing I'll tell you, what is that? So this is IREF, this is VDD, this is I0, this is the circuit, whatever above, this is VB. So here we have VDS1, VGS1, VDS1 is equal to VGS1, and we made this VDS2 is equal to VDS1 because we know this VDS, we have this value in our hand because of diode connected thing, that what is the value of VGS1 and VDS1, and accordingly we made this VDS2 using VB. Okay, so what is the minimum voltage required here? So minimum voltage required here for proper current matching is, what is the voltage here? VOV3. And what is the voltage here? It's not VOV, it's not overdrive voltage, it is same as VDS1. Okay, so V out minimum is, if we see it closely, it is VOV3 plus VDS1, VOV3 plus VGS1. Okay, so this is the one of the drawback, that what should be the minimum value. If we design the circuit, what should be the minimum value we desired? It should be VOV3 plus VOV2, or VOV3 plus VOV1, but here it is not overdrive voltage, but it is a gate source voltage. And what is the gate source voltage? Gate source voltage is V over drive voltage plus threshold voltage. So this voltage becomes V over drive of 3 plus, if we see here, V over drive voltage of 3 plus V over drive voltage of 1 plus VTH. Okay, so minimum thing we needed from the circuit, we assumed that it should be V over drive voltage of 3 plus V over drive of voltage of 1, but actual for the proper current mirroring, it is VTH, it is more than the overdrive voltage of 2. Above that we have the threshold voltage of 1 or 2. So extra threshold voltage required at the minimum voltage output here. At the minimum, at the voltage V out, minimum voltage requirement is above the 2 VOVs, whatever VOV3 plus VOV2, above that we needed VTH here. Then only this will work as a proper current mirror, matching current mirror. Okay, so this is the problem in this circuit. Okay, so the method of current mirroring, we know that we needed VDS2 is equal to VDS1. For that we have added this VB made such that this voltage is equal to this voltage and this voltage equal to this voltage. So this is the circuit and this is the problem, that we need extra threshold voltage at this node above 2 VOVs. Okay, thank you.